Okay, so we got this assembly here. Why can't the street come up? There we go. I'm going to open up the 3D data set. Whoa, what's going on?
What?
Oh, this isn't saved right at all.
That's not the way it opened for me.
It's all in hide.
Yeah. It should be.
This construction geometry is supposed to be in hide too. Everything goes in hide except for the solid in the part body. Okay. So I'm going to go into assembly. And in assembly, I'm going to do an interference check between all components. And it tells me that those two are touching. It says contact right here, which you think would be good, but in reality is if we design it to contact, that thing's going to get jig locked in there because there's no tolerance in there at all. So it's going to be stuck. Okay. So I'm going to close this off. And go back to our drawing. So when I get into, let's update this real quick. Go into this sheet. This radius must be greater than 2.5 so that this piece, if it were a stock 1/4 inch, would actually fit in there. Okay? You guys can reply verbally. You guys following me on that?
Yeah.
Yes.
Okay, thank you. So now what I like is this dimension, go to this shot, this dimension, they all fit. Uh-oh. Uh-oh. How did this get through? That can't be on there. Why can't that be on there?
Because it's double dimension.
Yeah, how did that get through, check?
It looks like Dave from ECO checked it.
Uh-oh.
According to the sheet there.
Yep, it looks like somebody's getting to talking to. Alright, so what I want you to do is in your book, we're going to work to RC3 tolerance, okay? So in your book, you see where it says RC3 on the top?
Mm-hmm.
We're going to look for a 1/4 inch hole. Okay? So the hole is standard, and the reason why that's standard is like if you got a 1/2 inch drill, when you drill it, ideally the hole is a 1/2 inch. You guys okay so far?
Mm-hmm.
So what we're saying is the tolerance, and it's working to what size here? Are in thousandths of an inch. So we're working to pretty tight tolerances here on a RC3. And I think that's what my notes say, use RC3. So we got 0.24 and 0.40 on the left side for the nominal size. You guys see that?
Mhm.
And you scroll over to the right and you see RC3, hole and shaft. So the hole is going to be this radius here, and the shaft is going to be what it goes into. Sorry, backwards. The shaft is going to be what actually sits on top for this case. The shaft would be the size of the bolt, typically. Okay, so the hole can be
thousands.
60 thou, right? Or sorry, the hole is, the limit is -0 plus 60 thou. Now that's if it were the hole. We got to do the opposite because it's not a hole. Okay. So what we're going to do is we're going to change this radius call out. I'm going to have to break down here. Go to my legacy preferences and get back into inches. Yikes. Do I have... I don't see my tolerances there, so I'm going to go to my properties. And I'm going to change my tolerance. To, I forget which one it is. Tolerance and number. The upper value is going to be 0.250. That's the most I'm going to let that become. So the least I'm going to go down is minus 0.006 because it's in thousands, right?
Yeah.
0, enter, apply. So that's saying the greatest this can be is 0.25, but it could be less than 2.5. Okay. Now I'm going to switch over to sheet 2. Okay. And I'm going to do tolerance on this one. According to that same book, my tolerance number upper value would be, anybody want to guess?
Negative 50 thou.
Be positive.
We got to go
Yeah, so it would be
positive this
positive
time.
on this one, yeah.
Okay, so you guys got to kind of think that through. So it's 0.0050 minus, anybody got a number for me?
Is that 90 thou? No, it has to be 0 though.
Oh, wait a minute.
Sorry.
You don't want it to get any smaller.
Apply. What I'm saying is it's got to be greater than 0.005 and greater than 0.009. Okay, because I designed it to quarter, but the tolerance is you've got to be at 2.550 or as big as 2.590. But I don't want it bigger than 90 because I don't want too much slop. And that's using an RC3 tolerance.
Would those numbers be swapped? Should the 9 be above the 5?
Yes. Because the bigger number goes on top, and then the smaller number goes on the bottom.
Okay.
Okay? Now, ask yourself, will this fit? If I go into here, what's the maximum size this can be?
Quarter inch.
Quarter inch is the maximum size. If this were the maximum size, and this were 2.509, would it fit in there?
Yeah.
Yes.
No.
What do you mean no?
Yeah.
Well, because it's the extra that
I'm
is.
so confused.
It would be extra bigger.
It's got to be extra bigger. So 255, that will still be big enough for the other piece to fit in its biggest scenario, right?
Mm-hmm.
And smallest scenario. So the biggest this radius can be is what?
0.259.
Thank you. And I go into the other sheet. The smallest this radius can be is what?
0.244.
What is the difference between 259 and 244?
A lot.
No, not the number I'm looking for.
No, I can't do that one in my head.
Can you guys do the math on that?
60,000, isn't it?
What?
I mean,
0.29.
oh, 259. I was going 2.25 to 2.44. Because I'm dumb.
So what's the number?
Let's see. The
Go ahead and type it in as soon as you got the number. What is the difference? From 259 to 244. Go ahead and type that in. I'm waiting for you guys to type her in.
uh,
15's way too huge. I need a decimal in there somewhere. Does everybody agree it's 0.015?
looks like it.
Look in the book. What does it say the tolerance is?
.05 to 1.5, or 0.5. So that'd be what, 50,000 to.
No. The tolerance is 1.5. Now, why is their tolerance reading 1.5?
In thousands.
Right, so you have to move the decimal over, right?
Yeah. It would be 0.015.
0.015, which is exactly what you guys wrote. So that is greatest tolerance. That's called the maximum condition. Okay, what's that called again?
Maximum condition.
So how would I calculate the minimum condition?
You would do the smallest opening to the largest shaft.
Okay, so what number would I use here?
0.0025 would be your number that you use.
And what number would I use here?
That would be 0.255.
And the difference between that is?
Less than the other answer was.
Yes, definitely. This is called minimum condition.
That's the MMC, right?
Yes. No. I can't remember now right offhand. This is minimum tolerance. So what's the difference? And what do you got for number?
5? 5,000?
Not 5. Can't be 5. 5 is 5 inches. Say that again. 5 thou? Is that what you said?
Yep.
What do you think, Mike?
Yeah.
Risto?
I put it in the chat.
Oh, thank you. So everybody got 5 thou? And in fact, isn't that what it says in the book?
Yep.
That's what those are now. So does that make sense? On how to put an RC3 tolerance on there? So I'm going to challenge you guys to do that. This is the final assignments for the class. And now it's just a matter of getting them all done. I'm going to pull this up. So on lesson 8, exercise 1, Rev A, you guys can pull that up for your own reference on your drawing if you want. Revise the part to fit using the RC3 tolerances. Basic whole system chart found in the tolerance chapter in the print reading book, which is chapter 10. We're going to do this for the exercise you did in lesson 8. Exercise, I should say 1, not 4. Oh, the 4 is an example because that's what I demoed. I meant to demo 4, but I actually demoed 2. But it's the same thing, same kind of concept. You guys, here's the neat thing. All I need is a picture of the drawing. Okay?
Okay.
The checklist, not required. Data set checklist, all those pictures, all that, not required. Only.
But we can do them if we want, right?
You can.
I don't have that time.
Only PDF of the 3 drawings. God. You only get 100 points because I'm not making you do all that other work. You only have to get the 3 drawings done. Actually, the rev is easier than the whole damn drawing. All you gotta do is do what I did that one time, right? Let me go back a class. Oh God, where did my 204 go? What happened? Ah, you suckers.
Well, I thought I saw it on there for a second.
Winter, summer. Is that really the last time I taught this class? I can't find the last time I taught it. Son of a gun. Okay, back to the drawing here. So, you'll add a rev note indicating that the drawing's been revised to allow for tolerance, to allow the 2 parts to fit, okay? So all you need is to make this one change on this one drawing. This one change, the Rev A up here, to identify where that one change is. Okay? And in the notes, you're gonna note that you've changed it to the RC3 fit tolerancing. Any questions so far?
Well, how would the assembly reflect anything? Because there's no dimensions on it. Would the assembly drawing note anything?
I was just about to ask that too.
Yes. The assembly drawing would have the same revision note, but there would be no flag notes indicating. It would just indicate the 2 parts were changed. And then you would refer back to the drawings to see changes.
Okay.
Okay? So there would be 3, all 3 would have a Rev A note on them.
Okay.
But you literally don't do anything on this drawing sheet. That makes sense so far?
Yeah.
Who checked this drawing? Where are the view callouts down here?
Looks like Dave Promecio again.
Son of a gun.
Look at that right there in the box. Says so.
You know,
This guy is
Drew this was really off his game that
letting
day,
her
though.
slip. Slip too much. Okay. All right. I hope you guys do a better job of checking than this Promasio guy. Okay. I'm going to. Let's see. Ann, did you find your assembly? Lesson number 1? Or is it, yeah, number 1? Lesson 8, number 1?
I totally didn't even think to look for it. Hold on 1 second.
Did you find it, Rick? Lesson 8, number 1?
No, I am actually looking for it.
Sean, or Mike, did you find your lesson 8, exercise 1?
I'm opening up my assembly now.
Sean, your mic is off. Okay, I made you presenter. Ann, can you show your screen?
You want the drawing?
Yeah, the assembly drawing.
Okay, it's loading right now. Ooh. Okay.
Oh, you gotta update the drawing so it can reframe. Can you go to sheet 2? Oh, that's nice.
Over there now.
Okay. According to this, what are we going to have to change here?
The channel.
Yeah, so what do we need here? What all do we have to change? What do you got to fix? Anybody?
You're gonna have to do the 2 outer sides.
Nope.
The inside.
I need the inside, and then what else has to change? Mike, what's got to change? Yeah, we got to get rid of that. Because we're not going to do 2x anymore. We're going to locate the shaft, but we're going to dimension the shaft so I control the size of the shaft. Now my question is, what is the tolerance, my friends, according to your RC3? And if it were me, I'd probably put the 1-inch dimension on the bottom. And you're going to group the 3 and the 4 as a chain dimension, if it will allow us.
Looks like it did.
Okay, so Mike, what size diameter am I looking for?
Let's see. On the whole, you want 0 and 60 thou.
60 thou. 60 thou? You agree with that, Rick? 60 thou?
Well, it kind of depends on which one you're looking at. The 0.40 is in 2 columns, actually.
Okay, good
It goes
point.
from 0.24 to 0.4 and 0.4 to 0.71.
So let's say we're going to go to the 0.4 to 0.71, okay?
Okay.
So what is
Then
it?
it's 70 thou.
70 thou.
7 thou?
7 thou, not 70 thou.
Oh,
Because 70 thou would be even looser tolerance than 30 thou. I'm putting in a tight tolerance to make
Right.
these things fit. These are to 7,000s. You following me, Rick?
I think so. I'm a little baffled.
Move the number over so we can see. So don't put any numbers in there. What's the greatest this can be? This notch. Anyone? What's the greatest it's going to be? First off, does everybody understand where I got the 0.7 or the 7 thou?
yeah.
Are you with me on Rick where I'm getting the 7 thou?
Not 100%.
Okay, so you're on page 205, right?
Yeah, 205 here in the RC3.
And you got on the left side, you got to go down to 5.4.
Gotta go. Yeah.
5.40 on the left side, right?
Yep. Okay, there it is.
And-
Okay, I got it now. I was on the wrong row.
Okay, so we're going to go from 0.4 to 0.71, and then we're going to slide it, which is really kind of, they should be at 0.41, but we're just going to go with that. So 0.40 to 0.71, and you slide over, the whole size is 0.7, which is 7 thousandths tolerance. So what's the greatest this number can be?
4.00 or 0.407, right?
0.407?
Or no, 007.
And what do you think?
0.407.
0.407? What do you
Yeah,
think?
07.
What is it now? What's the number going to be on top?
Not everybody at once, right?
Yeah, right.
407.
0.
0, right? 0.4070.
Zero.
Okay.
Yeah, that's what I meant.
And what was the smallest number that's going to be?
0.4000.
Yeah, because the tolerance is 0. So I'm saying the notch, because usually the hole is the nominal. And whatever shaft is going into it is going to be bigger or smaller. Okay? So, which tolerance did I use? Do you remember?
It was that second one down, wasn't it?
Yeah, tolerance num. Okay, and then what do we use for upper? And what do I use?
Oh, 0.4070.
No.
Wait,
Rick, what do I use?
0.007.
Yes, 0.007.
Is that just the variance in the number that's being,
Right.
that,
You literally,
Okay.
whatever tolerance they got, you just plug it in here. And what's the lower tolerance?
0.
All right, hit apply and see what it looks like. Okay, click over on the side there. There's your tolerance. Now you have to put a negative in front of the 0.
oh. Is there a way to do that?
You got to go back to the tolerances. You got to use a negative? Yeah. Oh, no, I'm sorry. It's 0. There is no negative. 0, you can't go negative 0. Okay. All right.
I thought that was a test.
Yeah, it was a test. So move you got no shoulder. Okay. Now go to your other drawing. According to what we just did, this is the shaft that's going to go into it, right? So guess what we got to change?
She needs to chain dimension that bottom
There's my stupid. Oh.
center edge there.
And we'll have to numdink it and change it to 4 places. Okay. If it were me now, I'm going to move that datum out because you got to group those dimensions. Okay, that looks better. I would try and get it away from that other text later on, okay?
Yep.
When we group this, hopefully we'll align everything. Oh, it doesn't look like it did, huh?
Yeah, because I think I split up this group. Hold on. I don't know if it likes it.
Honestly, sometimes I find it faster just to delete them and put them in. You might recall how I like to do the biggest one first and then work my way in. Something don't seem right.
What is going on?
Oh, we gotta numdink it, that's why.
Oops.
Okay, what's the biggest number that can be?
.4000.
Ann, you agree?
0.4060.
0.4060. Mike, you agree?
Yeah.
You all agree it's 0.4060. 0.4060. Can you go back to the other drawing, please?
Oh, yeah.
.4060 is going to be.
No, that would be the smallest.
There's no way that's going to fit in there, right? Because what's the biggest the hole's going to be?
0.4.
So 0.4060 is going to only fit if it's at the largest it's going to be. Okay, so if it's at 0.4, there's no way it's going to fit, right? So let's go back and reassess this. What should that number be? What's it say in the book?
Well,
0.3994.
0.394. That's the biggest number it can be is 0.394. And 0.394 will fit into 0.40, yes?
Yes.
Mm-hmm.
And what's the very smallest it can be?
0.39.
0.390.
0.
Okay, so let's change our tolerances. So basically, you can think of that piece that's going to go inside that notch as a stem, or the shaft. And the notch that it's going to fit into is the hole. So if it's a hole, a notch, you just got to think about what's fitting into what, right? Do those numbers look correct? Plus? We're going to go plus.
Minus. Yes. Sorry. We're good. I'm doing the number it's supposed to be.
You just had to put a negative in front of that.
It shouldn't just be the 0.0.
You just need the negative number in front of it. Type in a negative.
But that would make it minus 30.
How come you don't think Dave knows what he's doing? Can you type in a negative? On the top, type in a negative 0.006. Isn't that what the book says? And then a negative 0.001. Or no, negative point.
0.00.
Yeah.
Did you type a negative in front of that? Oh,
Right, dude.
shit. How come it won't take that?
It should take it.
It wouldn't let you type a negative?
It is. I'm just having problems.
See, you literally just type in what the book tells you, don't you? Isn't that exactly the numbers the book gave you? You don't even really have to think. You just put in the numbers. I hope you guys will think, though, and think it through, and ask yourself, 0.006 minus 0.40 is going to be 3.94. Does that fit into the hole I want it to go into? Are you guys following me on that?
Yeah.
What's the maximum condition here?
.4060.
No. And what's maximum condition?
1.7?
Oh no, it's 0.401, right?
No. Maximum condition.
Maximum is 0.4.
Oh, 0.3.
Sorry, 0.3. You got it. 9.4.
No. And what
Zero.
is it? And what?
Point 0.017?
How'd you get 0.017?
Well, the easy part is what the book says, but you take the...
Yeah, the book tells you.
Oh, for Christ's sake.
Maximum condition, the book says 1.7. Minimum condition is 0.6. But how did they get there? This, guys, you guys have to know. You guys cannot go into production and not understand this chart. That's
They
why we're going
subtracted
through
the
it.
maximum from the minimum, right?
Right.
Or,
So what's the maximum size the hole can be? What's the maximum size the hole can be?
where was that?
Go back to the other sheet, Ann, so I can see it.
0.4070
What did we just say on this sheet?
or 4007.
That's the maximum this hole can be, right?
Mm-hmm.
Okay. That's the maximum this hole can be. Now go back to the other one. What is the maximum size the shaft can be?
.39.
0.39 is the maximum.
Okay.
394.
Maximum size or maximum minimum size?
Maximum.
It'd be .3940.
Is 394 bigger than 3.9? 0.39?
Yes.
Okay, so the maximum this can be is 0.39. That's the biggest it can be, right?
That's the biggest the shaft can be.
Yeah.
And what's the smallest the shaft hole can be?
0.39?
No.
0.
Go back to the other drawing.
.4070.
Wait,
Go back to the other drawing.
40070.
Sorry. I meant to ask you what's the nominal size of the hole?
0.40.
Okay, nominal size of the hole is 0.4, right?
Yeah. Yep.
and the maximum size, no, the maximum size, no, the nominal size of the hole is 0.4, right? Nominal size of the hole is 0.4, and then when we go back to the shaft, the largest this can be is 394.
Yep.
And the difference is
0.005 or 6, yes.
right, 0.006. That's the tightest it's going to be. At the very maximum condition or minimum condition it can be and still fit is 0.006. Otherwise, if I get smaller than that, I'm saying it's not going to slide anymore because there's going to be too much friction. It's going to jig lock in there. Now, what's the biggest gap? What's the most slop I could have in there? How do I calculate the most slop?
You take your largest hole size and your smallest shaft size.
Right. What's the smallest shaft size?
0.39.
And what is the largest the hole can be and still be acceptable?
0.40070.
And what's the difference between the 39 and the 4070?
Oh boy.
0.015.
0.017.
017.
0.
Right? Get your calculator
Yeah.
out.
Yep.
Okay? And it comes out to 017, does it not?
Yes.
Look in the book. What does the book tell you the limits are going to be?
1.7.
Right. Okay?
Wrong again. Yeah, 1.7.
And that's the loosest it's going to be. And what's the tightest fit it's going to have?
60,000.
0.06.
0.006.
Or 6,000. Yeah.
Not 60 thou. That's 30 thou is engineering tolerance.
Yeah, I
Okay?
screwed myself up when I was looking at it.
6
6
thou
thou, right?
is pretty tight tolerance we're working with. But I want you guys to understand how to read tolerances and how to put them on a drawing. Alright, I made a recording of that. Uh-oh.